Hi, in this video I'm going to explain how to use assertions to check that the values that come out of a model are correct, and instead of checking them in a very tedious manner, checking every single value, we will just automatically check that everything is okay. And for that, in AIMS we have something which is called an assertion, which is something, an identifier with this symbol, this A we have here, and I will provide you with some approach which is very convenient to get all the information in a very easy way. You need to work a little bit first, and then every time you create something new in a model, you just need to run a procedure and check if everything went okay or not. So for that, we have here a very simple project where we have a declaration here, which is deck output parameters. And let's assume we are working in a model where we have projects in a set, sub as projects, and we have teams in a set which is as teams. And we have the indices e projects and e team for every set. And we are assigning projects to teams. And imagine we solve the model, we have variables and we dump those variables into parameters. In this case, we have this parameter, which is PV. P stands for parameter, V that comes from a variable, O1, which is a binary parameter, and assignments, which is defined for every subtuple eTeam iProject. And in this case, I filled it with values, sorry, which are of course 1 or 0. And for example, team 1 is in charge of project 1, and team 2 has no project assigned, and so on. In this case, clearly we have project 1 over assigned to teams. We will assume that a project can be assigned to just one team. And we have project 2 which has no assignment. So we want to run a procedure that identifies these errors and let us know that this is happening. Okay. For that, we have two procedures. Okay, we'll get back to them soon. And we have some identifiers, which are down here within the declaration deck check output data. The main identifier here main identifiers are these two assertions and the string parameter sp assertions failed, which will store the information corresponding to what comes out of the checking procedure. So this is a string parameter, and we will fill it in with information as we run the procedure. And the core of the thing are the assertions. Let's go to this first one, which is AWS team assigned to project iProject. So an assertion has a name, as any other identifier, an index domain. In this case, this means that for every project, we are checking that a team has been assigned to this project. So we'll run this assertion for every project because we need to check this for every single project. We have a property value which is warn only. I'll leave that to you to check within the AIMS documentation. And we have two main fields. One is the definition and the other is the action. The definition is which needs to be met. In this case, if we sum over every team the parameter PVO1 assignment, its item iProject, this must be more larger than 0, which means that at least one team should be assigned to every project iProject. If this is met, if this is something that the solution of the parameter is actually that something that happens, everything will be okay. But if this is not met, we have an action. In this case, we are running or we're calling up the procedure. Okay, we will get back to this soon. The other assertion, similar to the previous one, again, it has an index domain which is iProject. We check this for every project. It's a warn only assertion. And we have another definition here. In this case, if we do the other sum, in that case, in this assertion, we want it to be less than 1, which means that we only want a single team assigned to every project. Of course, we may have a more complex definitions. We may write if statements or other kind of things because here we don't need to have any specific a pair about the fact that it does not need to be linear. We can use any syntax that aims at needs, and it will just will just check for us if this is met or not. So in this case, if this is not met, again, we run another procedure, which is the same one we run before. Okay, we'll get back to this again. And these assertions are called within the main procedure, which is this one here, proc run output assertions. Let's check it out. What we do first here is we empty the identifier which stores the information as regarding the errors. So we empty so that we don't store any information from previous runs of the procedure, and we empty the value of number of errors stored in this other parameter, which is the number of errors. So what we do is first we use an auxiliary parameter, which is p number of errors subtotal. We'll get back to it. We don't need this right now. And after that, we run the assertion as team assigned to project for every project. So when we do this, what we are doing is running that assertion for every project and checking if at least one team at least is assigned to every project. Okay, so we do that, and every time we do this, we come here to the as team assigned, and if this definition fails, what we do is we run this assertion. This assertion does the following thing. This procedure does the following thing. We'll get back to it. It is a procedure which has an argument, an input argument, which is sp new fail. Okay, we can see that we have a declaration which is local to this parameter, which is sp new fail, which is a string parameter. It has an input value for the property, and what it does is the following. First, it introduces or it adds the information within this identifier, within this parameter, to the parameter which is storing all the information regarding the errors. So to the errors we had stored before, we add the next words, error, and the value of the new fail. And then we add a unit to the parameter pair number of errors. So if we go back here, for every project we run this assertion. We go to the assertion. If this is not met, we run this procedure, which means okay, write this, add this to the parameter which stores the information with all the errors. Okay, we call this assertion with this as an argument. So what we have here is the sentence unassigned, period, project, percentage E has no team assigned, I project. In this case, this formal string allows us to put this sentence here, which means that, okay, read the project that refers to this assertion and write that within this position, so that when the user gets the information, will read something like an assigned period project 1 has no team assigned. Okay, so we do this all the times that we need, which is as many times as project we have, and every time we do that, we call this procedure and we add a unit to this parameter per number of errors. So when we have done that for every project, we can check if this value has increased, because when we first began with this procedure, this was 0, this was 0 as well, and if we have run the assertions, and for example, there's two projects which were which result in in an error because there were no team assigned to any of those, this value would be, this parameter would be 2, this would be 0, and in that case, what we do is we just do nothing, but if these are the same, which is this is 0 and this is 0, in that case, that would mean that there are no errors. In that case, we add to this parameter this sentence. Check OK, all projects have at least one team assigned. Okay? This backslash n stands for an enter, so that we have a new line every time we type this. And once we have that, we have another set of sentences of statements similar to the previous ones, which do the same thing but with the other assertion. In this case, we first store the number of errors into this auxiliary parameter. We run the assertion for every project, checking if there's an overassignment for all these projects. And then again, if these two values are equal, it means that there weren't any errors. So we store this additional line to our assertions failed parameter. And if they are different, in that case, what we do is we don't add this, but we would have added something else within this procedure, because we would have called this procedure again from this assertion. And in this case, when this doesn't is not met, what we add to the string parameter storing all the information. In this case, we add overassigned project. Remember the symbol, which will take the value of the project that didn't meet the assertion, has more than one team assigned. Okay, so let's try how it works. If we check again the data, which was here for our parameters, you can see that we should get two error messages, or two lines. First, project 1 is overassigned because there are 2 teams that are assigned to this project, and project 2 is unassigned because there's no team assigned to it. So we right-click on the procedure, we run it, and we go to the data page of the string parameter storing the information. Right-click, data, and we get error unassigned. Project 2 has no team assigned. Error overassigned. Project 1 has more than one team assigned. Okay. We should do something which I didn't do. We should empty as well p number of errors subtotal, just in case, because if not, we will have some other value stored and we don't want that to happen. Okay. Again, we're correcting. Imagine we fix the issue with our model and we get different data dumped into our parameter, and we have now that project 1 is not overassigned, but project 2 is unassigned. So we run our assertions again, and now in our string parameter we get the following information. Check OK, no projects have been overassigned, so we fixed that. But still we have an error because there's a project which doesn't have any team assigned. Again, imagine we fix our issue with our model and we get now this result. Okay, we run our procedure again, and we check the data. All the checks were okay. Now, so we are comfortable now with our results. The great advantage of this approach is that we can create as many assertions as we want. We just need to extend this procedure with as many blocks like these ones as we need, so that when we want to check if our data is okay, we just run this and get all the information in a string parameter that we may add to a page, and we just see that and feel comfortable if all the checks were okay. The only warning is that we need to make sure that these assertions are well built. If not, we're confident, we might believe that things went okay where they went. So we need to make sure that we wrote the right code in these blocks and within the assertions. So I recommend creating sets of values which violate the assertions, so that we get the messages alerting us that things are not okay, so that when they actually are right, we can trust the results from the assertions. So I hope you can use these in your projects and make your life easier and your projects are more reliable. Okay, goodbye. Enjoy